Hello and welcome. In this example 4, we're going to look at finding the second derivative using implicit differentiation. So let's get started. Here we have 2x cubed minus 3y squared equals 8. To find the first derivative of y with respect to x, we're going to go ahead and take the derivative on both sides with respect to x. I'm going to write the ddx's. Which distributes to all terms on the left and the right hand sides. That's just by the properties of the derivative. I don't know why I'm writing these backwards. And that's a 2y squared. So now we're going to take the derivative term by term. We have the derivative of 2x cubed with respect to x, which if you multiply the 3 in front gives you 6x squared, right? Subtract 1 from the exponent. And now when we're taking the derivative of 3y squared with respect to x, the variables are different, so we're going to use our implicit differentiation, or more specifically the chain rule. We're thinking of y as the inner function. So the 2 will multiply in front to give you 6. Then we'll leave the inner function alone, subtract 1 from the exponent here to give you a 1. Then we have times the derivative of the inside function with respect to x. So times dy dx. On the right side, derivative of a constant is 0. Now we're going to solve for dy dx. So we'll subtract the 6x squared to the right, make it negative. And then divide both sides by 6, or negative 6 in fact, and divide the y over, and we'll get x squared over y. So the negative 6's cancel, and we just have x squared over y. So that's the first derivative of y with respect to x. Another way we could write it is this is y prime, right? Y prime and dy dx are the same thing. Now to find the second derivative, we're going to take the derivative of the first derivative. So the second derivative, which we can write using Leibniz notation like this, or squeezing it in, this is y double prime. That's another way of writing that. We're going to take the derivative of the first derivative. Where the first derivative is x squared over y. What rule are we going to use to take the derivative of x squared over y? If you said the quotient rule, that is correct. Time to break out in song. Give me a moment to write quotient rule. Low d high minus high d low over low squared. If that song came out of nowhere, then go back to Packet 5 and watch those videos for full context. Okay, so there's the quotient rule. We got to take these individual derivatives now. So we have derivative of x squared with respect to x should give you 2x. Then we have the derivative of y with respect to x. Well, that is dy dx. I'll just write dy dx over y squared. And actually, dy dx we have already. That's x squared over y. So we can go ahead and plug in x squared over y for dy dx. Let's do that. X squared over y. There we go. Now, it's usually not good manners, I guess you could say, in math to leave a fraction inside of a fraction. If at all possible, it's good to clear out the little fraction that's inside of the bigger one. So faux pas, you might say. And we can do that by multiplying the top and the bottom of the big fraction by the LCD of any little fractions that we found, like that x squared over y fraction, which is really x to the fourth over y. So when we do that, we're going to get 2xy squared minus x to the fourth over y cubed. And there's the second derivative of y with respect to x. Notice again that it's a function of both x and y, right? All these implicit differentiations will often have an x and a y in their derivatives. Thank you for watching, and see you in the next video.